Okay, hey guys, we're talking about more about confidence intervals. So, and remember the whole premise behind confidence intervals is to talk about inference. I to the N to the F to the E to the R to the E N C E. Oh, I got it right the first time. Now, as we are looking at this, our overall objective here is we're estimating for a population mean. So here we're talking about the confidence interval for a mean, which means a confidence interval is going to be for, as I stated right here, the population mean. You can see the two sections in your book that's applicable. Now, when do we use this? Well, the reality is everything we just did was all about percent. And when we are doing the probability of finding a sample mean, we are not always given our standard deviation for the population. So like for instance, remember today when we were doing the Hershey's Kisses, we weren't given a standard deviation. Okay? Because if I asked you what was it on average if I looked at 8 sample sizes, I should say we had 5 sample sizes of 8 pieces each. We did not have a standard deviation for the entire population. I mean, seriously, who pays attention to how often the Hershey's Kisses land on the base? However, we had it of the sample because we could have easily put it in the calculator and crunched it in. So, what happens if we don't know that standard deviation for the population? Well, we have to use a different distribution. And here the t distribution. We use this when sigma is Okay, it cut me off at some point. So let's go back to this. I use this formula right here when I have a z star. And I use the z when sigma is known. But what happened when it's not? Because like I said, we did a activity and I could have easily asked you, instead of for p hat, I could have asked you for the average times it landed on its base. Well, like I said, nobody knows the population, standard deviation, so that means I'd have to use this formula. And this takes us to a completely new distribution. So the question is, what type of distribution is used? A t-distribution is used when your sigma is unknown. So notice right here, here's your t. That means we're going to be using t star. Also, again, that replaces the sigma, again, because we don't have the values. So as I go to page 7, the questions are, what are the characteristics of a t-distribution? Well, you know it's coming from an SRS, because it has to, otherwise it's biased from the start. Okay, we have sample size n, and yes, it still has to come from a normal distribution, but sigma is unknown. And I know I'm repeating myself, but see, that is the key difference between t and z. Sigma is unknown, therefore we cannot use a z, we must use a t. A key aspect to having to use a t is we need what's called a degree of freedom. And the degree of freedom is represented by n minus 1. And we're going to be finding that information from our TAN sheet, that t-distribution sheet that I gave you guys a few days ago. But before we look at that sheet, I want to say something that does make sense. As our sample size increases, our t-distribution starts to look like a z. Well, we know sample size increases the mantra of statistics. Okay, so let's look at our t-distribution and let's pull this all together. Let's look at our degree of freedom, how this is applicable, that a t-distribution starts to look like a z. Okay, so first of all, as we're looking at the 2015 AP Free Response question chart that was given on the AP test, at the bottom it says page 16. There we go. Please notice something. Here, are all your probabilities. Your probabilities are all up here. Okay, now I'm going to highlight mine, but you cannot highlight yours. Matter of fact, let me pause. Okay, so you can see right there are your probabilities. You've got your 0.25 right there, your 0.2, your 0.15, 0.10, 0.5, etc., etc., etc. Now, again, you cannot write on yours. Let's look at what's called the degree of freedom. The degree of freedom are all these values right here. You've got 1, 2, 3, 4, etc. So what that means is, as I wipe this clean, if I'm looking for a sample size that happens to be 9, and I have a degree of freedom, which means if n equals 9, technically, let me wipe this clean and I'll do it again. When n equals 9, what I have to look for is n minus 1, which is 8. I've got to look at that right there. And then as I look at that, I've got to find a T star, a score that's associated with that 8, which is the sample size minus 1. And then what I do, let's say that I'm looking at a probability of 20%. So I look at this, I go down, I go over, and that 0.889 is my answer. So it's kind of have a Hannibal Lecter here. It's inside out, because before we were given the probabilities in the body with our Z. The probabilities of X were in the body, and then our scores were out here and out here. Well, that's the Z. For the T, you recognize that here are the scores. Okay, now let's look at another example as I take this chart off. Okay, so I want to slide down to 55, and as I slide down to 55, I am looking for my T star. Now, before when we had Z star was referred to as critical value, and now that it's T star, it's the same thing. So here, I'm going to look at it slightly different than I looked at it before. I am going to find my degree of freedom, which is 9, because what's that, 10 minus 1, and I'm going to go to the bottom and look for the 95% confidence interval for the bottom, and I'm going to go up and then over and find the value. The way I was doing it before works, and we're going to talk about more when I could use that method, but the reality is going from the bottom up is easier. So let me transfer over so we can see what that value is. So I have my 95% confidence interval, and I'm going to slide up until I get to that degree of freedom, which was 10 minus 9. So I'm up, 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 up. Right here. So I can see my T star for this is 2.262. That is my T star. Next, I want to look at part B. So I have 20 observations, so that means my degree of freedom is going to be 19, and I'm looking at my level C to be 99%. I need to wrap this up. Okay, so here's my 99%. Here's my degree of freedom. And I'm just going to take this and slide it like this so that I can see right there that 2.878 is going to be my T-star. Right there. Now I want you to do problem 55C. And as you look at this, recognize, here's your 90%. There is no 70, what am I looking for? There is no 76. So I'm just going to have to go with the closest one. So you can go with the 1.664 or the 1.671. Right there. Last, because I want to wrap this up, I'm already talking too much. Please recognize your three conditions are no different than they were before. Okay, however, for normality, can't use n times p, that's a proportion. But you're using what some would say is CLT, but they don't use it quite often for that. CLT usually goes for the Z distribution, but you're looking at a large sample size, which is considered greater than or equal to 10, or you have a normal distribution, or remember a normal probability plot, which we'll remind ourselves as we continue on. Okay, also our formula, I'm just repeating it. So I've gone over, I'm so sorry. I will see you guys tomorrow. Have fun doing your homework. You're right, but have fun.